So logarithms were discovered or invented because of this problem. If I have 2 to the x equals 8, can somebody tell me what x is? X is 3, because 2 cubed equals 8. But if I have 2 to the x equals 5, we have to use logarithms to find that number. It's going to be a decimal. 2 squared is 4. 2 cubed is 8. So it's going to be 2 point something, okay? And you have no idea of how to get that unless you use logarithms. So when you use logarithms, you will get that answer. And we're going to learn that in a couple of days. But today we're going to do things that can be simplified to where you don't need to use logarithms, okay? So let's... So this one, we factor 243 to 3 to the 5th, 27 to 3 cubed, and then we have 3 to the 5r equals 3 cubed, and make the 5r equal to 3, and then find that r equals 3/5. Okay, so we don't want exponents in the basement, so we're going to move them upstairs. What do we know about 16? What is it? What exponential thing can we turn to 16? 4 squared. So this would be 1 over 4 squared, all to the 3n minus 1 equals, what about 64? Is 4 to the what?
4. 5.
4 cubed.
Oh, okay.
If 64 is 4 to the 16 and 4 times 4. You could have brought the 16 down to 2, 2 to the 4, and the 64 to 2 to the 6. Either way, as long as you make the two bases the same. But those bases are downstairs. We're going to move them upstairs. What do you do to an exponent to move them? You change them from positive to negative or negative to positive. So this is going to be 4 to the negative 2 equals 4 to the negative 3. Everybody get that? And now I've got negative 2 times 3n minus 1 equals negative 3. So negative 6n plus 2 equals negative 3. Negative 6n equals negative 5. N equals 5/6. So if we could find a way exponentially, this is not like 5 times 5, but this is exponentially, to change both of these bases. The bases are the guys that are holding up the exponent. So think of 25 as 25 to the 1, right?
Yeah.
So 5 and 25 are the two bases. If I could figure out a way to change 25 to base 5, what would it be? 5 what?
Divided by 5.
Not division or multiplication, but exponential. 5 to the what?
Negative second.
5 squared is 25. So this is going to be 5, 3p plus 3 equals 5 squared. Now, this is the question. If 5 of this mess equals 5 of that mess, what do we know about the two messes? They have to be what?
The same.
So we just make them equal to each other. 3p plus 3 equals 2. 3p equals negative 1. And he said it. It's negative 1/3. Okay?